So today what we're going to do is we're going to talk about compound interest, and we're going to talk about compound interest with more specifically different periods. So basically what you need to know in a compound interest is calculated at regular intervals and added to the account. So this is the same thing that we were doing last day. So we're always going to use this formula. A is equal to P1 plus I to the N, where A is the amount, or also known as the future value, or the amount of the compounding. So this is the money at the end, if you think about it. And this portion here represents the start value. I'm relating this to what we studied in exponentials. This is called the start value or the present value. And then this portion here, I, is the interest per compounding period. Now, usually we get our interest in years, and then when they tell us what our compounding period is, we actually take that compounding period and divide by whatever take the interest and divide by that compounding period. Now, the N value is the number of compounding periods. This is the number of compounding periods. Now, because we're humans, you and I, we basically think of things in years. But in this case, when we talk about compounding periods, we just take N and multiply by take the years and multiply by the compounding number, which we will discuss in the next portion of this note. So, when we talk about something that is annual, we're talking about the number of calculations per year. Annual means there's only one calculation per year. When it's semi-annual, there are 2. When it's quarterly, there are 4. When it's monthly, there are 12. When it's weekly, there are 52. And in the end, daily means 365. Here's a special note. In this case, I is equal to the rate that we get for the year. And what we're going to do is we're going to divide that by the comp number. Whatever it is that relates to that number. So if I say my interest is compounded quarterly, I take whatever percent that I know that I have for the year and I divide by the comp number. As for N, N is the number of compounding periods. So if it's done semi-annually, N, for the most part, is equal to the years, and then we times it by the comp number. Unless the compounding is already described for you in the specific thing. So if I said I'm doing my compounding daily, and I say that it comes in days, N is just 200, and if I say that 200 days have gone by, then that's it, N is 200. But if I tell you it's years, it's going to be the year times 365. So the next thing that we're going to do is we're going to do the calculations for this stuff, right? So here we go. It says determine the future value of the following investments. We have $2,500 for 3 years at 4.2% compounded annually. In order to do this in about 3, 4, 5 steps, what we do is we always start by writing out our apron. Every time we work with compound interest problems, we always start by writing out our apron. Now, it says determine the future amount of the following investments. $25,000 for 3 years. So, invested at 4.2% compounded semi-annually. So, this number 2,500 is the present value, P. This portion here represents the years, and this portion represents the rate. Our R value that we're talking about right here. So let's do our calculations and punch this into our equation. So we're going to start by writing out 2,500 for P. We don't know what A is. We have R being 4.2%. And I usually write 4.2 divided by 100 is equal to, do our calculations, we get 0.042. You guys have difficulty changing these decimal percents. So I want you to write 4.2 over 100, calculate your answer, and then use your answer for the other part. Now, this portion here, it talks about our stuff being semi-annually, right? It's semi-annual. That means that our comp number is 2. So here we go. I, in this case, is 0.042, and we're going to leave it as a division of 2. Now, we're doing this for 3 years, so n is equal to 3, and then we times that by 2, which gives us 6 compounding periods. So the very next thing that we do is we're going to just quickly write A is equal to P1 plus I to the n. You always write the basic equation, then do our substitution based on apron. We get 2,500, 1 plus I, not 1 plus I, 1 plus 0.042 divided by 2, raised to the 6. And all you're going to do is you're going to punch that directly into your calculator. You're going to write 2,500 plus 0.042 divided by 2 raised to the exponent 6. You do your calculation and you'll get the following number. And we end up with $2,265.61. Following the same pattern that we have from before, we'll always write our apron. So in this case, 3,800 is our starting value, so that is P. This is the years, and this is actually 3.5 years. When it says 3.5, it's 3.5. Now this portion here represents the rate, which is really 5.5%. So let's do our substitutions accordingly. In this case, P is equal to $3,800. R, A I don't know about. R will equal basically 5.5 divided by 100, which is going to equal 0.055 on your calculator when you do it. Then you take I is going to be 0.055, and we divide by 2. We divide by some number? So this portion here represents our comp number, and our comp number in this case is going to be 12. So we're going to divide by 12. And then for n is 3.5 years, so we're going to take 3.5, and then we're going to multiply it by 12 to get 42 as our answer. Doing the appropriate substitutions, we get the following. A is equal to P, 1 plus I to the n. We substitute directly in 3,800. 1 plus 0.055 divided by 12 raised to the 42. and we get $4,604.63. So now what we need to do is we need to look at the next problem in this set. We need to determine the interest earned on $1,750 invested for 5 years at 6.1% compounded quarterly. Because we're saying that it's compounding, we have to always bring out our apron. A, P, R, I, and N. And what we're going to do is we'll just do our full substitution. In this case, we've got the following. 1750 is our P value, our starting value, and it's vested for 5 years. And this is our 5 years, but this part is going to be our rate. We don't know what A is, and we'll just substitute directly in. And now our rate is 6.1 divided by 100, which is equal to 0.061. And I use my calculator to check that sometimes. And then we have our interest rate, but it's compounded quarterly. So that means our comp number is 4. So that means we're going to go and take 0.061 and we're going to divide this by 4. And then we're going to take our 5 years and we're going to multiply it by 4 to get 20. We do our basic substitution, so we get A is equal to P1 plus I to the N. We'll substitute 1750. 1 plus 0.061 divided by 4. And we're going to raise that to the 20. When you do your calculation, you get A is equal to $2,368.83. And the last thing I could ask you for a problem like this is, what is the interest? What's the interest that's made? In order to do that, our interest is I is equal to the A minus the P. Taking the future amount minus the present amount, or the starting amount. And what we do is we just subtract them. So we have 2368.83, and we're going to subtract it from 1750. And we end up with approximately $618.13 for our interest. So anytime they ask you for interest, that's all you're doing. You must start by subtracting A minus P. Now, your homework is not this, what you see here. Your homework is this. Your homework is from lesson 3, which is on the website. And it's for compounding with different interest, different periods. And you're basically going to do number 2, 5 to 8, 11, 14, and 17. Good luck.